Welcome to this DevTV presentation on the AutoCAD.net API. This is Session 3, AutoCAD Database Fundamentals. The main objective of this session is to understand how to use the API to access and create entities in an AutoCAD drawing. We will do this by focusing on the AutoCAD drawing database and how you use transactions, and more specifically, how transactions are used with the AutoCAD.net API to create entities. When you work on a drawing in AutoCAD, it may look like you are creating graphics. It is true that what you see in the AutoCAD editor is graphical. However, what is really happening is that a database of AutoCAD objects are being created, and these entities are being rendered on the screen. The database contains and organizes the entities in a hierarchical fashion. When you save the drawing, the database is in the DWG file. When the drawing is opened, the database is placed in memory. All the objects in the database have an object ID that is unique in the AutoCAD session. This object ID is similar to a primary key in a relational database. Also, many objects refer to other objects and may require them to exist, such as a line needed to have the layer that the line is on to also be in the drawing database. It is helpful to see the organization of the AutoCAD database. There are the symbol tables that have been in AutoCAD drawings since release 12 of AutoCAD. These symbol tables are used for elements such as layers and line types. The block table contains model and paper space as well as other blocks. These blocks, which are block table records in the API, contain the entities that you see rendered in the AutoCAD editor. The named object dictionary contains dictionaries that were introduced in later releases of AutoCAD. New functionality that is added in AutoCAD will often use the named objects dictionary. Examples of this are layouts and plot settings. The database also has variables that are unique to that drawing. Now let's drill down and explore symbol tables in more detail. The symbol tables store symbol table records such as a layer table record and line type table record. All of the symbol tables have methods that allow you to add a new record. They also have an item property and a has method that allows you to find if a symbol table record already exists in the symbol table. The symbol table can only contain records of a certain type. The layer table, for example, can only contain layer table records. The block table is similar to other symbol tables. However, it contains block table records. In AutoCAD, what you see as a block is a block table record in the API. The block table record contains the entities that you see in the AutoCAD editor. The two block table record, model space, and at least one paper space block table record will always exist in every drawing. You can search for a block table record using a string with the name of the block or an object ID. The block table and symbol tables are automatically created when you create a new drawing. There is an example that will be useful when we are learning about the AutoCAD drawing database. This is an ARX example called ARX DBG. You can find this example in the Object ARX SDK in the Samples Database directory. Using the snoopdb command from this example, you can see the contents of database objects such as the block table and block table records. Let's take a few moments and use the ARX DBG example to examine an AutoCAD drawing. Here's AutoCAD 2011. I'm going to run the appload command and load arxdbg.arx. Notice where it's located under Samples, Database, ARXDBG. So it's successfully loaded. And when I right click now on the context menu, I have an ARXDBG item and I can choose Database Info. And this tool will be very useful for you to understand what a drawing database looks like. What we're focusing on mostly now is the symbol tables, and we want to look at the block table. Under the block table in a brand new drawing is three different block table records. One of these is model space. You can see that it's an ACDB block table record. And there's two paper space block table records. These are for layout 1 and layout 2. In the drawing in model space, if I click on entities in block, I get a message that says there are no entities within this block. So let's go ahead and draw an entity. I'm going to draw a circle. I'll run the circle command and draw this circle here. And then snoopdb, database info, in the block table and model space, you see entities in block. We now have one circle. The class name is ACDB circle. But there's no other blocks yet. So we can go ahead and create a block. We'll say OK to that. Let's draw a line and an ellipse, I guess. So we have these two entities, and I'll run the block command. We'll name it test and put a pick point here. Select the objects. Say OK. Run the command again, and look at the block table. Now we have a block named test, and within test you see the two entities, the ACDB line and ACDB ellipse. We do see them in the AutoCAD drawing being displayed, and we know that a block like test wouldn't be drawn in the AutoCAD editor. So if you go back to model space and look at the entities, you'll see now that there's an ACDB block reference, and this is how the entities are being displayed. The block reference belongs to the model space, and the block reference references the block test, as you can see here. The block name indicates that it's referencing that block test. So hopefully this tool here can be very useful to you. I would recommend getting it and help you understand what an AutoCAD drawing database is made up of. So let's go ahead and head back over to our PowerPoint slides. The AutoCAD.NET API will allow you to create an AutoCAD database. This can either be a new one or one that you can populate with a DWG file. The most common workflow, however, is to get the currently active database. There are two ways to do this. One is to use the working database property of Host Application Services. The other is to use the database property of the MDI active document, as in the C# code snippet. When we use the AutoCAD.NET API, we will most likely be using object IDs. Every object will have an object ID, and it is unique throughout the session of AutoCAD. This means that even with multiple drawings open, there will not be any two objects with the same object ID. The object ID is automatically generated when the entity is added to the database. We will use the object ID with transactions to open objects for manipulation. Using transactions makes working with the AutoCAD.NET API easier, and it is the recommended way to access objects in the AutoCAD drawing database. There may be times that you need to open an object directly, but that will be very rare. A transaction creates a boundary for your code. They allow you to handle errors cleanly, and transactions operate with a single undo filer. The transaction needs to be committed to have the changes that your code made to be permanent. If the transaction is aborted, then the changes made in the transaction are rolled back. Another thing to keep in mind is that transactions can be nested. What this means is that if the outer transaction is aborted, then so are the nested transactions, even if they were committed. Here we see an example of creating a transaction. After we get the database, we declare a transaction named trans. It is created using the start transaction method of the transaction manager of that database. A transaction has a commit method that we use if everything went fine. If there was a problem, we will call the abort method. Always remember to explicitly dispose the transaction. This is often done in the finally block of the try-catch block. We use the getObject method of the transaction to open objects. We use an object ID with this method. We'll also need to set whether to open the object for read, write, or notify. In many cases you will want to open the object for read, test some of its properties, and then upgrade the object to open for write if you need to make changes to the object. This example shows how to open the block table for write. Notice that the database has a block table ID property that we can use for the object ID. In this more complete example, we can see that we are relying on the using keyword to dispose of the transaction. Notice that if everything was successful, the commit method of the transaction is called. In your code, you will want to also use a try-catch block so you can gracefully handle any error that may occur. In the catch block, you can tell the user there was an error and take appropriate action. You would not need to dispose of the transaction explicitly, however, because the using keyword will take care of that for us. In the previous slide, we saw an example that opens the block table. The example did not do anything to the block table or add any new block table record. Here let's focus on how you would add an object to the database. First, you would need to find the right object to add the new object to. If we are creating a new layer, then we would need to add a new layer table record to the layer table. If we want to add a new circle to the drawing, then we would need to append it to either the model space block table record or the paper space block table record. Remember to always use the add newly created DB object of the transaction to let the transaction know about the new object. This diagram shows some of the managed classes. Notice that in the .NET API, all of the objects inherit from DB object. Objects like lines also inherit from curve and entity. You can see here a couple of other objects in the drawing database, such as block table. It is helpful to understand a few things about memory when we use the AutoCAD.NET API. The managed objects in the .NET API are wrapped by unmanaged C++ objects. When we use the new keyword to create a new object, you do not need to dispose of them because of the .NET garbage collection behavior. If the object is disposed and it is not in the database, the underlying unmanaged object is deleted. If the object is database resident, the underlying unmanaged object is closed. If we use a transaction, which we will do most of the time, disposing or committing the transaction closes the unmanaged object. Now let's put these ideas we covered in this presentation about the AutoCAD drawing database, object IDs, and transactions to work by going through Lab 3. In Lab 3, we will use the API to create a circle, block, and block reference. Here is Visual Studio. Let's open the lab project. File, Open, Project Solution, Lab 3. Here's the code that we added in Lab 2. And if you scroll down, you'll see the beginning of Lab 3. The first thing we need to do is declare a database variable and instantiate it. But we need to add the database services namespace for the database and transaction. So let's go do that. We'll just use the imports keyword, and then Autodesk, AutoCAD, and then database services. I'll scroll back down to the lab steps. Now we can go ahead and declare our variables. So this is dim. I'll just call this DWG as database. And we'll make that equal to the editor, document, and then database. So the editor was created in Lab 2. Now we need to get a transaction. We'll go ahead and do that. Dim trans as transaction. And that will be equal to the database and then Transaction Manager, and then Start Transaction. So in step 3, we need to add a try, catch, and finally block. So I'll just type in try. We need to move the catch above step 9 and the in try below step 10. And we'll want to finally block right here. And that's where we'll dispose the transaction. Now we can move on to step 4. We need to create a circle. We'll use the new keyword, and we'll use the prompt point result that we had created in Lab 2. We need to use the geometry namespace. So let's go ahead and add that right now. So we'll type in imports and Autodesk, AutoCAD, geometry. Scroll back down to step 4. I will dim a circle. Circle, and that will equal a new circle. We'll use the value from our get point result that we created earlier in Lab 2. And that will be the center point for the circle. The normal for the circle we can get from vector 3D, and then the z-axis, and our radius will be the get radius result value. So that is the circle. You can see with IntelliSense that it wants a center, a normal, and a radius. And so we've provided those with these values we've got from our prompt point result and get radius result that we had from Lab 2. And that will create a new circle that exists in memory. Now we need to actually add it to the drawing. So we need to go ahead and do that. We'll instantiate a block table record. We'll call that BTR. And we'll use a transaction to get the model space block table record. So I'll type in trans and then get object, and then I'll use the current space ID of the database that we instantiated earlier in the steps, and we'll open that for write. Now we just need to add the circle to the model space block table record. So we just call BTR append entity, and we pass in our circle. We also need to tell the transaction about the new circle. So let's do that. We'll call trans and then add newly created DB object. And this DB object is that circle, and we want to add it. So we'll pass in, make the argument true. And then we need to commit the transaction by calling the commit method. So then in step 9, if we had a problem, we already have the EX as exception there, so we don't need to add that. Then we just need to use the right message of the editor. Let's go ahead and do that. So ed.write message, and it's something like problem due to, and the exception message to string. And then finally we want to dispose of the transaction. So well, maybe I should just put it below the instructions. Okay, we're not done with the lab steps. There's another section where we actually create the block and the block reference, but we can run this now and see if our code is okay to create a circle. So I'll go to debug and then start debugging. Alright, here we are in AutoCAD 2011, and I'm going to run that load. And let's load up the lab that we're working on. AutoCAD.NET Labs, Lab 3. Let's turn off the grid. And let's just run our command. And you see it asks me which ending do I want to create. I'll type in circle, pick the center point and the radius, and this time we see a circle created in model space. So our code is working okay. We put a breakpoint in somewhere here. Let's just put it at our try catch, I guess. Be alright. Try block. Run the command again. A circle. And we can step through the code. Let's just go ahead and take a look. Go to debug and step over. And we get the code for creating a new circle. Do that again. And you can see that all the code just seems to be working fine. Where we are appending the circle to the block table record, adding the object to the transaction, letting the transaction know about it with the add newly created DB object, and then the transaction gets committed. So let's go ahead and continue, and the new circle is created. So now let's just go ahead and continue on and create the block. So I want to stop debugging and move on down to step 11. Here we need to declare a database variable again because we're in a different case select. Remember we had a case select. If the user wanted to create a circle, the code above would get run, and here they're going to create a block. So I'm going to use dim dwg as database equals the editor document database. We need a transaction again. And remember what we use for this. We use the transaction manager and then start transaction. We'll add another try catch block here. We need to move the catch above step 36 and the in try below 37. Let's do that. And we'll want to finally block right here. And this is where we'll dispose the transaction. We need to declare a block table record, and we'll call this new block def. That's block table record. We'll just make that equal to a new block table record. Let's give it a name. So we got the name from the block name result variable that we asked the user for in lab 2. So block name result, and then we'll just use the string result. This will be the value that the user provided. So we need to declare a variable as a block table. So block table as block table. Let's use our transaction. Get object. For the ID, we'll use the block table ID property of the drawing database, and we'll open that for read. We need to use an if-then statement and test to see if the block table already has a block that we want to create. So we'll use the has method of that variable created in step 16. If block table, we'll use the has method and use the result, the string result of our block name result that equals false. We need to create the new block reference. Move the indif below step 35. Now let's move on to step 18. So the block with that name does not exist when we get here, so we need to upgrade the block table for write, because we opened it for read. Let's just call the upgrade open method on that. And we'll add the block table record that we created in step 14. We'll use the add method of the block table. So block table, add, use the new block definition, or that new block table record, and in 20 we need to tell the transaction about that new block. Add newly created object and the new block def, and add as boolean. Make that true. Now we need to add some entities to that block. We just created an empty block, so let's create a couple of circles, and then we can add that to the block. So dim circle 1 as new circle. The circle is asking for the point 3D, normal, and radius as we saw earlier. Let's give it a new point, 3D. We'll just put those at 0, 0, 0. And we can use vector 3D for the normal. The vector 3D z-axis, and the radius will be 10 in this case. Okay, so that'll create that circle in step 21. In step 22, we want to append the circle to the block table record. We use new block def, and then append entity, and append circle 1. Step 23, we create another circle. Call this one circle 2. We'll change the center point to 2010 using the same normal, and the radius can also be the same, just leave it at 10. Let's append that other circle to the new block def. So we've added the circles to the new block. Earlier we added the circle to model space block table record. Here we're adding the circles to our block table record called new block def. But we also need to tell the transaction manager about these new circles. Trans, then add newly created object, circle 1, and here again was for the second circle. So we have a new block definition, block table record, and now we'll actually use that block and add a block reference to model space. So this will be something that will actually be displayed in the AutoCAD editor. We need to get the insertion point of the block, so we're going to use a prompt point options to do that. So let's call it block ref point options. A new prompt point option. This asks the user to pick the insertion point. We need to test the return and get the value from the prompt point result variable that we'll create here. And what do we pass in? We pass in our prompt point options that we created in step 26. Block ref point options. Let's just use an if-then statement and test that prompt point result. Block ref point result status is not equal to OK. We'll go ahead and try to dispose of the transaction and return. So we need to move our end if below step 30. And in step 29, we want to dispose of the transaction, and then we'll return. So if something happens when we're getting our point from get point, then we'll dispose of the transaction and return. So in 31, if we get here, we know that we've got a point, and we can go ahead and create a block reference in model space. So here's our block reference. We'll make this block reference in memory. For the insertion point, for the position of the block reference, we'll use the block ref point result value, And the block table record will be the block definition that we created. I need to use the object ID. So now in step 32, we need to get the current space, either model space or paper space. So I'll dim a variable called current space or CUR space. This is the block table record. Trans.getObject, and we use the database and then the current space ID, because this could either be model space or paper space, and they will open that for write. We'll use the append entity method of the block table record created in step 32, so that would be current space, and then append entity, and let's just append our block ref. And tell the transaction about our new block reference. If we get here, everything has gone fine, and we'll commit the transaction by calling the commit method. If something goes wrong, let's tell the user about it. We'll use the editor and the write message. Say something like problem occurred because, and use the exception message to string. And finally, remember we need to call dispose. And that is the end of the lab steps. Let's try the code out. I'll hit F5, start debugging. Now AutoCAD has started up. Let's run that load. Load our code. Type in add an int. This time we'll create a block. We need to give it a name. Getting the insertion point for the block reference. And the code seems to have worked fine. So let's run it again. Want to add a circle this time. Center point, radius. We have our breakpoint hit, and our circle was created. Those are the steps for Lab 3. Thank you for watching this DevTV presentation, and good luck with your efforts on Lab 3. We'll continue the AutoCAD.net API training in Session 4, where we'll show how to use the AutoCAD.net API to create database events and to use the palette set.